Let's talk about the number e. This is Let's Learn Real Analysis Part 14, and today we're going to talk about maybe one of the most important numbers in all of math. What's so cool about e is it shows up in all sorts of different places. For instance, take $1 and invest it at 100% interest, compounded continuously. How much money will you have at the end of the year? You're going to have exactly $2.718, and that's the number e. Look at functions like 2 to the x or 3 to the x, and you look at the slopes on those graphs and you ask, what is the derivative of one graph or the other? Well, it turns out there's only one of those that is its own derivative. That's e to the x. That's super magical. Like, why that number? You look at area under this graph, 1 over x. It turns out that if you want exactly the area to be 1 square unit, then you've got to stop right here at e. That's so fantastic. It actually turns out that this sum here, if you keep going forever and ever, it gets closer and closer to that same number, 2.718. Ultimately, in math, we would have to show that all of these different things are all equal to each other. We would start with one, show it's connected to this other one, and we could do all of that. But today, I'm just going to show that this sequence here, where we add one more term each time, is actually converging to something. And that will be what we'll start as our definition of e. And then from there, if we wanted to, we could connect it to all the other things. And so if we notice, each time we're adding one more term, one more positive amount, so this sequence is definitely increasing. It's actually getting bigger, even if it's only by a tiny amount. So by the monotone convergence theorem that we learned last time, as long as we can show that this sequence is bounded above, that every term is less than some fixed value, we'll be done. I'm actually going to show that every term of this sequence is less than 3. The way we do that is simple. So imagine you have something like 4 factorial, that's 4 times 3 times 2. That's definitely a bigger number than 2 times 2 times 2. And similarly, all of these terms, if we just replace all of the factors with 2, then we can see that this sum here is going to be less than the sum below it. And that is what's called a geometric series, which we can add up in a lot of different ways. Maybe I'll make a separate video about that. I've got some more below on the TikTok. But if you work this out, this converges to the number 3, and therefore every term of our sequence is going to be less than 3. So we have an increasing sequence, we have a bounded sequence, therefore it converges to something, and that's our definition of e.